Solve the linear Diophantine equation of 5x plus 3y which is equal to 4 for all x belongs to integer z. Here the given equation is of the form ax plus by which is equal to c. Therefore this is a linear Diophantine equation. Therefore here a value is 5, b value is 3 and c value is 4. Next we have to find the GCD for a comma b, that is 5 and 3. We have to find the GCD of 5 and 3. Here we have to divide this 5 with 3. Therefore consider like this, we have to divide this 5 value with 3. Here 5 is a dividend and 3 is a divisor. Here we have to find a quotient value. Here we know that 3 into 2 is 6 which is greater than 5. Consider less value, that is 3 into 1 is 3. We have to subtract 5 by 3. We get a value as 5 minus 3 is 2. So 2 is a remainder. Here 5 is dividend, 3 is divisor, 1 is quotient and 2 is a remainder. Next step we have to divide this divisor value with the remainder. So take like this, we have to divide 3 by 2. Here we know that 2 into 1 is 2. Next step we have to subtract 3 by 2. We get a value as 1. So 1 is a remainder. Next step we have to divide this divisor by 1. So take like this. You have to divide 2 by 1. We know that 1 into 2 is 2. Here 2 minus 2 is 0. Therefore we have to stop a division method here. Next step we have to find the GCD, means GCD is nothing but the last non-zero remainder in a division is a GCD value. Here we have to stop this division method when we get a remainder value as 0. So this previous to this value, this is a last non-zero remainder. Therefore we can conclude that GCD which is equal to 1 because this is a last non-zero remainder. Hence we can conclude that the GCD of 5 and 3 is 1. This procedure completed, that is finding GCD value is completed. Next we have to verify that D divides C or not. Here the GCD of 5 and 3 is 1. So this is the value of D, and we have to verify that D divides C, that is C is 4. So D divides C is nothing but 1 divides 4. We know that 1 divides 4. We can take this as 4 is equal to 1 into 4. So we can conclude that 1 divides 4. So this condition verifies. Therefore the equation has a solution. This is the first step, that is first we have to find the GCD. Using the GCD value we have to verify that D divides C or not. If D does not divide C means the equation has no solution. If D divides C, the equation has a solution. Next step we have to find the particular solution for this given equation, that is to find the particular solution for 5x plus 3y which is equal to 4. Here to find the particular solution means you have to apply division algorithm method over here. Using division algorithm method, this division method gives a value like this, that is we can write it as 5 is equal to 3 into 1 plus 2. By division algorithm method we have to write the dividend value as divisor into quotient plus remainder. So that is division algorithm method. So with the help of division algorithm method we can write it as dividend is 5 which is equal to divisor is 3 into quotient is 1 plus remainder is 2. In the similar way we have to take the division algorithm method for this. Here 5 is equal to 3 into 1 plus 2, or we can take this value 2 as 5 minus, here take this value to the left hand side, we get as 5 minus 3 into 1. Call this as equation number 1. Next we have to find the division algorithm method for this value also, that is we get a value as 3 which is equal to 2 into 1 plus 1, or we can take this as 1 which is equal to 3 minus 2 into 1. Call this as equation number 2. Here no need to take this division algorithm method for this value since the remainder is 0 here. To find the particular solution for the given linear Diophantine equation, we have to use division algorithm method for this fraction. Next step, take this equation number 2. From equation 2 we have 1 is equal to 3 minus 2 into 1. We have to substitute in the place of 2 as 5 minus 3 into 1. So consider equation 2 and substitute 2 value with the help of equation number 1. It is 1 which is equal to 3 minus, here we know that 2 is 5 minus 3 into 1 into 1. Next step, multiply 1 inside the bracket, we get as 3 minus 5 into 1. Here minus 2 minus plus 3 into 1. Here we have 3 into 1. Here also we have 3 into 1. If we add this value we get as 1 which is equal to 3 into 1 plus 1 minus 5 into 1. Here we know that 1 plus 1 is 2. So take the equation as 1 which is equal to 3 into 2 minus 5 into 1. Here taking this equation, next step we have to multiply throughout the equation by 4, because to obtain an equation is of the form 5x plus 3y which is equal to 4, that is linear Diophantine equation. Here in the place of c, here we have 1 but c value is 4. So to achieve that c value we have to multiply throughout the equation by 4. We get a equation as 4 which is equal to Here in the right hand side, the equation is of the form 5x plus 3y which is equal to 4. That is, to achieve that equation type, we have to multiply 4 by 2 and we have to multiply 4 with 1. We get as 3 into 4 into 2 is 8 minus 5 into 4 into 1 is 4. Here if we multiply 4 for this, we cannot get an equation of the form 5x plus 3y which is equal to 4. So to obtain a linear Diophantine equation, we have to multiply throughout the equation. We have to multiply the values for this, the not for 3, and here also we have to multiply the value 4 for 1, not for 5. So we get an equation is like this. Next step, we can take this as 4 which is equal to, here multiply minus inside the bracket, we get as 5 into minus 4 plus 3 into 8. So we can conclude this is of the form 5x naught plus 3y naught. Therefore, we can take this value as 5x naught plus 3y naught, where x naught value is minus 4. Here comparing this to equation, x naught is minus 4 and y naught is 8. So this is a particular solution for a linear Diophantine equation. Here we have already discussed the statement, that is, if D divides C statement holds, we can take the linear Diophantine equation as a solution. We get a value as x naught and y naught. So we get an equation is of the form 5x naught plus 3y naught, where x naught is minus 4, y naught is 8. So this is a particular solution for a given linear Diophantine equation. Also, next step, we have to find a general solution for the linear Diophantine equation, which is given by the formula x is equal to x naught minus b by d into m and y is equal to y naught plus a by d into m, where m is some integer. So substituting b value, a value and d value, also x naught and y naught value, we get a general solution as, that is, x is equal to, here we know that x naught is minus 4 minus, here b is, we know that b value is 3 and d value as, d is nothing but gcd, d value is 1 into m as it is. Also y is, here y naught is 8 plus a value is 5 divided by d is 1 into m is as it is. So we can take this as x is equal to, here minus 4, here 3 by 1 is 3 itself. So we can take it as minus 4 minus 3m and y as 8 plus 5m. Therefore, we can conclude finally as x is equal to minus 3 minus 4 and y is equal to 5m plus 8 for all m belongs to z is a general solution for a linear Diophantine equation. So this is a procedure to find a linear Diophantine equation.